So let's work on kind of putting together the stuff that we've learned so far, and let's make a paper, rock, scissors game that the user can play with the computer. So we want the game to, let's do the end condition is going to be when either the user or the computer wins 3 games. So we're going to have a main function and we're going to have some helper functions. We'll figure out what these are going to be. We don't know how many yet. I'm just sort of drawing some things. But I need to kind of think about the most important thing I want to think about first is my data. So what sort of data do I need? Well, I need the computer's play. So I can call this comp choice. And this is going to be random. So I'm going to use the random module to figure out, to just determine randomly what the computer is going to pick. And then I'm going to have my user choice. So the user gets to pick paper, rocks, or scissors. Now, to make it easier for the user, I'm going to let them use P for paper, R for rock, and S for scissors. But to make it easier for us, when we're generating something randomly, we're going to use 0, 1, and 2. So we're just going to generate a random integer, and we'll say that 0 means paper, 1 means rock, and 2 means scissors. So our computer choice is going to be an integer. Our user choice input, we've got to get this as input. So we're going to generate that computer choice randomly. We're going to get the user choice as input, and it is going to be a string. It's going to be a single character, either P, R, or S. And then we need to be able to compare those and determine the winner. So the basic things that we need to do is we need to get the user input and we need to make sure that it's something we can use. So we want to be able to validate this so that they don't give us a 25 or a Lamborghini or a J or whatever, something that we actually can't use within the computer. We need to generate the computer choice, and then we need to compare these and determine who's the winner, and we need to keep track of how many games there are. So we should have some sort of welcome. So this is going to be a welcome helper function just to give the instructions, welcome/instructions. We could have a helper function that handles the computer's choice, so returns us a random number. And let's have a helper function that's going to get us the valid user choice. So it's not just going to get the user choice, it's going to make sure that it's valid and get new input if it's not valid. And then let's have another helper function that determines the winner. So we can call this determine winner. So if these are going to be our helper functions, we have to think about what they do. So welcome is just going to print. Computer choice is just going to return us the computer choice. The valid user choice needs to get the input. It's not going to be a parameter. It's just going to use the input function to get input from the user, and it's going to return the user choice. So we've got some things returning here. And to make these easier to compare, the computer choice can generate a random integer, and then let's turn that into P, R, or S. So let's return a string here, and we'll return a string here, and then we can easily compare those two strings. If we can't really compare a 0 and a P, although we could make a compound statement, and we'll talk about that a little bit more when we do this determine winner function. This has to take parameters, though. It needs to take the user choice, it needs to take the computer choice, and it needs to return the winner. So it's going to take 2 strings, and it's going to return us, let's just make it a string. We'll return either the computer or the user as a string. We could, make it a Boolean, true is the user wins, false is the user loses, something like that, or it could be a number. We'll just make it a string. So main needs to use these functions. It needs to print the welcome. It needs to use computer choice to get a computer choice. It needs to validate the user choice to get the user choice. And then it needs to determine the winner. And this also needs to have the loop that ends when someone wins 3 games. So a big piece of this main loop here is going, or this main function here is going to be the loop that actually controls the game. And in this case, the game is controlled by whoever wins 3 games. We could make it that you could play forever until you quit. That would be legitimate. We would just set our loop up differently. In this case, we're going to go ahead and make it as soon as the computer or the user wins 3 games, we're going to end the game. In here, the user choice will also have a loop to trap the user in a validation loop until they return us P, R, or S, and we'll figure out how that's going to work. But this is our plan. So we always want to plan before we actually start writing code. That way we can get ourselves nice and organized, everything structured before we start writing code, so we don't write ourselves into a corner. So we have our plan. We're going to have a main function. It looks like we're going to have 4 helper functions. We've kind of set up how we're going to do our data. So now we want to actually write the code. So the first thing I'm going to do is just set up stubs for all of my functions. So I want to have a function that prints the welcome and instructions. And we're going to call this def print welcome. And we're just going to pass. I'm going to have a helper function that generates and returns a random selection for the computer. And let's call this comp choice. And we're just going to pass on that. We have a helper function that is going to get and validate user choice. So we'll call this user choice. We'll just pass for now. And then we want to have determines and returns the winner of the round. And we'll call this def determine winner. We'll just call it det winner and pass. And this is going to have to take a computer choice and a user choice. So I'll just go ahead and add that in now. Now we've got our main function, and def main, pass on here, and we have our call to main. So here is our sort of outline for our program that we're writing to make our paper, rock, scissors games. I'm going to go ahead and run it. I don't have any syntax errors with my function headers, so I'm in good shape to get started. And I can either do my helper functions first, or I can do my main functions first. It doesn't really matter. Let's go ahead and do our helper functions first. So we'll just start with our print welcome. And we're just going to print welcome to paper, rock, scissors. The first to 3 wins, 3 round wins the game. So we're just going to let the user know how the game is going to work. Let's see. We should let them know they'll be playing the computer. So you can't play with a friend. We could modify it so you could play with a friend. That would be fun to do. You will be playing against the computer. So we've let the user know what they need to know about the game. They're going to be playing against the computer. First to 3 rounds wins. So this is pretty much all we need for this function. So we're going to, let's get rid of these extra spaces here. And let's go ahead and call it and see if it works. Print welcome. There we go. Our print welcome function works, so this is completed. Let's move on to getting our random selection. So we are missing our import statement. If we want to be able to use random, we need to import it at the beginning. So we've got random, and now let's get our random. So we can call this, comp equals random.randint from 0 to 2. So we're going to have 0, 1, and 2. Those are going to be our possibilities. 0 for paper, 1 for rock, and 2 for scissors. Now we could just go ahead and return this and make a more complex selection statements to determine the winner, but to make direct comparison easier, I can just throw some if statements in here and say if comp equals 0, return a P for paper. Elif comp equals 1, let's return an R for rocks. And our only other option, because we can only get 0, 1, and 2 in this case, is our scissors. So we're going to return S for scissors. So now we have paper, rock, scissors. All right, so let's make sure this is working by printing this function call to comp choice. So comp choice returns it. So if I just called comp choice by itself, it would return something, but I wouldn't be able to see what it returns because I haven't done anything with that. So I'm going to go ahead and print comp choice so I can see what it is actually doing. So we got an R the first time. So let's run it again. Second time we get an R. Run it again. The third time we get an S. Run it again. And we get an R again. Let's make sure we can get a P. R really likes R's. Not very random. P, we get a P. So we get all of our options. We don't get any errors. So it looks like that function is ready to go. So our next function is going to be our user choice. All right, so to get input from the user, we've got to use the input function. We're going to get strings, so we don't need to cast it as anything. So we'll say enter P for paper, R for rock, or S for scissors. So we let them know what we want. And now we're going to trap them if they don't give us what we're looking for. So we either want a P, an R, or an S. So we're going to check for that. So we're going to say while UI does not equal a P and UI does not equal an R and UI does not equal an S, then we're going to trap you. So let's cut and paste this right down here. So this is our set. We're setting our condition here. Here we're checking our condition, and here we're updating our condition. So we'll say you must enter P for paper, R for rock, or S for scissors. So they're trapped in this loop. So note the importance of the and here. Any of these will make it fail. So if they haven't entered one of these, it's true. So if it doesn't equal this, and it doesn't equal this, and it doesn't equal this, then they're going to be trapped. But the second they enter one P or one R or one S, this will become false and they will get out of the statement. Another thing that we can do is handle in case they enter a capital P, we can make their input lower before we check it. So we can do each of these dot lower, and we're going to talk more about these string functions that are available next week when we get into strings, but it's good for you to see it now. It just makes it handy so I don't have to also include and, UI does not equal capital P, UI does not equal capital R, and UI does not equal capital S. I'm just going to send it to lowercase before I make this comparison. If I ever get out of this loop, I've been given what I want, either a P, an R, or an S, and so I'm going to return this. And actually, now that I think about it, you know what? I want to make it lowercase because the computer's always going to be lowercase. Well, actually, I can return it down here. So what I want to do, let me open this up a little bit so we can see it a little bit better. And actually, let's just go ahead and close that and maximize this. All right, so once I get out of the loop, I'm going to return UI dot lower. All right, so now this will work. This will work perfectly fine. Actually, let's test it and let's make sure that it works. So let's call, instead of comp choice, we know this works. I don't need to test it again. Let's call user choice. All right. So if I enter a Z, I'm trapped in a loop. If I enter a bunch of garbage, I'm trapped in a loop. If I enter numbers, I'm trapped in a loop. If I enter a capital P, I'm fine, and it's going to return that lowercase p. Awesome. Let's double check that it works for R and S. So if I enter R, perfect. And let's run it again. If I enter capital S, should also work. So, but we've used this an awful lot where we had to bring it to lower to test it and then also bring it to lower to return it. It may actually be, it actually is shorter for us to say, let's just resave in the same variable the UI.lower, and then I can actually get rid of it everywhere here. So I'm actually just going to take it to lowercase before I do the comparison, and then I can just return it as it is. So let's go ahead and make sure I didn't break anything. Make it so we can see it. And I'm going to say a capital R returns a lowercase r. Run it again. I'm going to do a capital P, returns a lowercase p. Run it again. I'm going to do a lowercase s, returns a lowercase s. So, all right, now we've actually got our user choice and our computer choice, and our next step is going to be determining the winner. So now we need to code our function that is going to return the winner. We're going to send it the computer choice, we're going to send it the user choice, and it's going to return who is the winner. So we can handle, well, let's take a look actually. Let's plan this out. All right, so we've already got our structure scheduled here. We've already got everything that we need. So I can go ahead and clear this out. And now we're really going to think about how to determine the winners. So there are, for paper, rock, and scissors, there are actually 9 possibilities. So let's see what it is. We've got the user and the computer. If the user chooses paper, the computer has 3 choices: paper, rock, and scissors. If the user chooses rock, again, the computer could choose paper, rock, or scissors. If the user chooses scissors, again, the user can choose paper, rock, or scissors. So we have 9 possible outcomes: paper, paper, paper and rock, paper and scissors, rock, paper, rock, 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 scissors, and so on. If the user chooses paper and the computer chooses paper, this is a tie. Just the same as if it chooses rock and rock, it's a tie. Scissors and scissors, it's a tie. If the user chooses paper and the computer chooses rock, paper covers rock, so the user wins. If the user chooses paper and the computer chooses scissors, scissors cuts paper, so the computer wins. If the user chooses rock and the computer chooses paper, paper covers rock, so the computer wins. If the user chooses rock and the paper chooses scissors, rock beats up the paper, so the user wins. Again, with our user for scissors and paper, scissors cuts paper, so the user wins. And if the user chooses scissors and the computer chooses rock, rock crushes scissors, so the computer wins. So these are the 3 cases that we need to handle with our code. These are sorry, there are 9, but we can handle them in 3 cases. So we can do this a number of ways. So we could handle every single case separately. So we could actually have 9 different selection statements. That's totally legitimate. That will work. We could handle the ties in 1 statement and then do the rest, the other 6 in 6 separate statements. That would totally work. I'm going to handle it in 3 statements: the cases where they tie, the case where the computer wins, and the case where the user wins. So I'm just going to make 3 separate cases here. I'm going to divide our 9 cases into 3 selection statements. So the ties are pretty easy. If C is equal to U, if the user has R, the computer has R, those are going to be equal. I'm just going to return the string tie. Elif, the computer, So here I'm going to handle the case, and actually let's go ahead and make this look nice. We're going to have comments. So these are the tie cases. So then I'm going to handle the computer wins cases, and then down here I'm going to handle the user wins cases, which really only these 9 things can happen, so I can actually just have an else. So I'm going to handle my elif is going to be my computer wins cases, and then I'm going to have an else, and that's going to be all of our user wins cases. All right, and in this case we're going to return computer as the winner, and else we're going to return, and we should make this consistent, so let me put this on top of the else statement. Here, return user. All right, so now our computer wins cases. So let's look over here, the cases where the user wins, and I probably should have written these a little bit closer together, but if the user chooses paper and the computer chooses scissors, the computer wins, right? Because we're interested in these particular cases. And actually, let me make my life a little bit easier by just rewriting these. So I'm going to say these are paper for the users. This is rock, and this is scissors. So those are the 3 cases that I'm interested in. All right. Right here. If the user enters paper and the computer has scissors. If the user enters rock and the computer has paper. If the user enters scissors and the computer has rock. So these are the cases that I need to handle. So I have if computer equals a S and the user equals a, doesn't matter if you use 1 or 2 quotes. So this is one case. So if the computer is an S and the user is a P, that would be one case that the computer would win. Or there is the case where, and I'm not going to use spaces here just because I want to get this all on one, just to be able to see it for a little bit longer. All right. So we've got or. So or if the computer is a P, whoops, lowercase p, and the user is a R, right? So the user has paper, the scissors cuts the paper. So in this case now we're looking at the computer has the paper and the user has a rock because the paper is going to cover the rock, which I never really understood, but we'll just go with it. All right. Or so now we've handled the case where the computer had scissors, we've handled the case where the computer has paper. So the last case is when the user selected a rock, and the winning condition for the computer would be if the user has entered scissors, because the rock is going to crush the scissors, which does make sense. All right, so now let's open this back up, and this looks pretty good. I need a colon there. So I've handled the tie cases when the computer and the user are equal. I've handled the computer wins cases. There are 3 of those, and if they didn't tie and the computer didn't win, in that case the user wins. You could have made this an LF and done all of the user version of winning. This just saves you some typing. Invalid syntax. All right, I've got an extra parentheses there. Let's see what else we've got. And actually, to be able to actually do this, I want to print determine winner. And I've got to send it something. So let's send it with the computer as a rock and the user as a scissors. So this should be a computer wins case. So let's check it out. Computer wins. Awesome. All right, so now let's run it again with the opposite. So this should be a user wins case. User, Awesome. And now let's check out the tie case. And you would want to test all 9 cases to make sure you didn't have a typing error. Tie. Awesome. I'm just going to test these, but you would want to go through and test all 9 cases to make sure that you didn't mistype something or misconstrue something. Because, for instance, in this case, you want to make sure that it doesn't have an error on any of those 9 cases. And there's only 9 cases, so they're easy to test. If you have infinite cases, which is true for a lot of software, you just have to come up with as many cases as possible. So now we have all of our helper functions working. So we have to think about what we had for our main function. So our main function lets the user play until either the user or computer wins 3 games. So we're still going to print our welcome, and we just want to do that once, so that's going to be outside of the loop. And we're going to use counters. We're going to count the number of games that the user wins, count the number of games that the computer wins, and that's going to be what our condition is for our loop. So we need to set our loop condition, and our loop conditions, in this case there are 2. We have comp wins, and we're going to start it at 0, and we have our user wins, and we're also going to start that at 0. So this is our condition. As long as these both are below 3, we're going to continue playing. So we want while comp wins is greater than, or sorry, less than 3, and user wins is less than 3, because in this case, if either one becomes 3, we want to break out of that loop. So if this becomes false or this becomes false, we want it to quit. So this is why we're using an and. If we did the negative, if these are not equal to 3, we could use the or case. All right, so well, once we've got our conditions set up, actually let's test this loop. Our conditions are going to be within our if statements, but let's just check this really quick. Let's just do comp wins plus equals 1 each time through, and so the computer after 3 times should actually why didn't that win? Well, this is less than 3 and that is less than 3. Oh, I need to print. All right, let's print comp wins and user wins. All right. Got to make sure we have our testing statements or we cannot see what's going on. So this is what happened. So first it had won 0 games, then the computer won 1, then it won 2, then it won 3, and then it quit. So that's exactly what we want, as long as the user wasn't winning any. And it wouldn't have mattered if they were winning, and those went up to 2 and 1 and those kind of things. This will work out because it's just until one of them gets to 3, then we're going to break out of that loop. All right, we can get rid of this. All right, so now let's actually play. So the first thing we need to do is we need to get our computer choice, and we get that by calling comp choice. And this is going to send us a P, an R, or an S for the computer. Then we're going to get our user choice, and that's going to be gotten by calling our user choice validation function. And this is what code is going to run. It's going to get input from the user and eventually return us either a P, an R, or an S. Now we need to see who wins. And this is going to be equal to the determine winner function called with our comp C, which is the computer choice, and our user C, which is our user choice that we got from our 2 functions. We're going to compare the P, the R, and the S that comes back from this, and what's going to come back is either tie, computer, or user. So we need to use this value to say if who wins equals computer, we need to increment our comp wins variable. Elif who wins equals user, Then we need to increment our user wins variable. And now we want to make sure the user knows what's going on here, so we can print out, print after we get the user choice and the computer choice, not before. Before we determine who wins, we could print to the user something along the lines of print computer, and you could do this after the determine winner, it doesn't really matter. Computer chose, comma, comp C, and the user chose, just reiterate their choice here, chose user C, and then we're going to determine the winner, increment each one, and we're going to say, we'll say if the computer wins, print computer wins. Else, if the user wins, we can print user wins. And there's other ways to do this. There's no one right way to write a program, although there is lots of wrong ways. Else, we're going to print, if nobody won, we're going to print it's a tie. All right. Then the only other thing we need to do is once this is ended, once we've gotten out of this loop, one either comp wins or user wins has gotten to 3, we need to actually check this. We need to say if comp wins equals 3, print, we should say wins this round. User wins this round. There is no ties for the game. We're going to print if the computer wins, computer wins the game because they made it to 3 first. And then we're going to say else because there is no other possibility. It's only going to end when either the user or the computer gets to 3, so a tie isn't possible. We're going to print user wins the game. All right. All right, so this should be what we need to play our paper, rock, scissors game. All right, we're going to be playing against the computer. So I'm going to pick a paper. Computer chose S, the user chose P. The computer wins this round. Ooh, all right. I'm going to go with paper again. Computer chose P, user chose P. It's a tie. Let's go for a rock. It's a tie again. Let's go for another rock. I win this round, so now we should be tied. Let's do rock again. Computer wins this round, so computer's at 2 games. I win this round, so now we're 2 and 2. The computer won this round, so the computer wins the game. So if you continue to play this and test it, we shouldn't have any bugs, but let me know if you find any. But here's how we write a paper, rock, scissors game. So this uses everything we've done so far. We had to recognize patterns. We had to make abstractions, the paper, rock, scissors to be represented by the P, the R, and the S. We had to come up with an algorithm to do our code. And we had to decompose the problem. We broke it down into steps. We decided what our helper functions were going to handle for us, and now we have a working paper, rock, scissors game. So try to expand it. Make a paper, rock, scissors, lizard, spot game. Change it to be tiger, elephant, television set, right? Try to change it to make it represent things differently, or instead of it being 3 games, make it to 5 games. Make it to where the user can play and play and play until they quit, and then it tells you how many games the computer won and how many games the user won. So try some different modifications to make sure that you understand how this code works, and have fun.